Hello, in this video we are talking about section 6.3, which is on partial fraction decomposition, or the method of partial fractions. We are looking at example 1, which asks us to evaluate the integral of x cubed plus x over x minus 1 dx. Now we have just talked about when we can rewrite a rational function using a sum of simpler fractions. First off, we need a proper fraction. So a proper fraction means that the degree of the numerator is strictly less than the degree of the denominator. Oops, denominator. There we go. So this is something that we have to check, so it's a question mark. The degree of the numerator in this case is 3. The degree of the denominator in this case is 1. So we do not have a proper fraction. So in other words, we have an improper fraction. Whenever we have an improper fraction, we first need to apply long division with polynomials. So I will go through the details of the long division in this example, and if you need more help reviewing long division, there is a link in the lecture that you can look at. So we are going to take our denominator and divide it into our numerator. So that's x cubed plus x. Now we have to think, what do we multiply x by in order to get to x cubed? So that is x squared. Then we take x squared, multiply it by the x, so that we get an x cubed. We get x squared, we multiply it by the negative 1, so we get negative x squared, and then we subtract. Now x cubed minus x cubed is going to give us a 0 x cubed, and then if you notice here, we can take our plus x and move it down a little. This is the same thing as having plus 0x squared plus x plus 0, okay, for our constant term. So we're going to have 0x squared minus, well, but it's minus a negative. So we would have minus the x cubed, we would have plus x squared, so that's going to give us plus 1x squared. And then we're going to move down the rest of our terms, plus x plus 0. Now we need to think about, what do we multiply x by to get an x squared? Well, that is just an x. So now we do the same process. Multiply the x to each one of our terms so that we get an x squared minus x. We subtract all of that. So then when we distribute the negative, we'll get a negative and a positive. So then we have x squared minus x squared, which gives us a 0 x squared. We'll have x plus x, which gives us a 2x. Okay, and now last, oops, let me get a little bit more space here. Last, we need to, let me get another color, figure out what we need to multiply x by in order to get 2x. So that is 2. Repeating the process, multiplying the 2 to each one of our terms. We're going to have a 2x minus 2, and we subtract that so that we end up with a 0x, oops, 0x, and then plus 2. And 2 is our remainder because it has a lower degree than the denominator, which is x minus 1. So whenever we get a lower degree there, then we stop with our division. So what we have here is that x cubed plus x over x minus 1 is the same thing as we are going to take the x squared plus x plus 2, and we're going to take our remainder term, and the remainder term has to be divided by the denominator. So we have plus 2 over x minus 1. Now, the reason why we use long division is, remember that we're trying to integrate. So we have the integral of x cubed plus x over x minus 1. If x cubed plus x over x minus 1 is equal to x squared plus x plus 2 over x minus 1, then the integrals of those two things must be equal. So x squared plus x plus 2 over x minus 1 dx. Now, let's think. We have x squared, we can integrate that. We have x, we can integrate that. 2, we can integrate. And even the 2 over x minus 1 we can integrate. So the integral of x squared is going to be 1/3 x cubed. The integral of x is going to be 1/2 x squared. The integral of 2 is going to be 2x. That should be a plus there. For the last term, you can use a very simple u substitution. If you'd like, u would be x minus 1. du would be dx, so there's no constant to account for. You end up integrating 2 over u du, which is the same thing as 2 natural log absolute value of u. So plugging u back in, that's a simple enough u substitution that I would let you get away with not writing anything there. Plugging back in for u, we're going to get 2 natural log absolute value of x minus 1, and then of course we need to remember to add c. So, in summary, the integral of x cubed plus x over x minus 1 dx is equal to 1/3 x cubed plus 1/2 x squared plus 2x plus 2 natural log absolute value of x minus 1 plus c. And there's our final answer. So in this case, we didn't actually have to do a partial fraction decomposition. All we needed to do was apply long division. So remember, when you have a rational function and an integral, first check to see if it's proper. If it's not, apply long division. And then, depending on the situation, your remainder term might be complicated enough that you would have to use a partial fraction decomposition, but we'll see that in future examples.